Okay, so it looks like we're rolling here. So what we're doing today is we're factoring. Okay, so this might be a new term for you, maybe not. But let me move my desktop around. Okay, so what we did before, right, is we took some multiplication of polynomials. 2x plus 1 times 3x plus 4, and we would have applied a process to it, right? We did the FOIL method first, outside, inside, last, where we multiplied the first terms, got 6x squared plus 3x, because 1 times 3x is 3x. I'll move this down. And then outside 2x times 4 plus 8x, and then 1 times 4 plus 4. Combine some like terms when we get 6x squared plus 11x plus 4. Okay, so I think we're all pretty confident with this process going this direction. But how do we go from this back to that without knowing what any of this is, right? If we had no idea what came before, how do we go back to multiplying two things together to get this? Okay, well, to answer that question, we really want to take a step back in the kinds of expressions that we simplified, right? So let's look back at something that we did kind of when we got maybe 2 weeks ago, where we did 2x times 3x squared minus 9. Okay, where we simplified this sort of an expression. Okay, and this, because this is just a monomial times a binomial, we just use the distributive method, right? So we would do this times this, and then this times this. So we would get 2x times 3x squared equals 6x to the third. 2x times negative 9 is negative 18x. Okay, so we can see that there's a process to go from this to this. But like the other kind of more complex thing, and this is where we're going to start, how do we go from this expression and find out how did we get there, or what two things did we multiply together in order to get this? All right, so let's look at some examples. Okay, so let's say we have 12x squared plus 18. Okay, and we think, what two things would I have to multiply together to get this? Because sometimes when we're dealing with equations and expressions, we need to pull expressions like this apart in order to cancel things, or to multiply things, or to make something make more sense. We need to pull some things apart so we can simplify. So what we're doing is trying to figure out what this beginning thing was. And in order to figure that out, we need to do a little bit of investigating, right? Especially when it comes to the numbers. When we're dealing with the variables, it's definitely a little bit easier, but we'll get there. Okay, so we have to go back to our good old friend, the greatest common factor, the GCF. All right, and that's really the starting point. So let's figure out, well, the starting point and kind of the ending point as well, but that'll make a little bit more sense as we go along. So what we want to find is, since we have a binomial here, essentially, and a binomial, we're trying to figure out, is this two factors, right? And factors are just factor times a factor equals a product. That's just the basic kind of language of multiplication. So what we want is a monomial factor times a binomial factor to give us this new product. And the way we can figure out this monomial is the greatest common factor of these terms. So I think as we get some practice with this, it'll make some more sense. Okay, so we can think of these terms as just, well, let's just calculate a greatest common factor. Okay? So one way to do it is, sometimes you'll just have a feel for what it is. What's the greatest number that's going to divide evenly into these numeric parts of our terms? Right? What's the biggest number that can go into these two terms? Well, they're both even, so we could divide both by 2. But then we get 6 and 9. Well, 6 and 9, well, those are both divisible by 3. So we wouldn't really be done. One way to do it so that we make sure to get really the greatest common factor is we just do a factor tree. Right? We find the prime numbers that all add up or multiply together to give us these numbers. Okay, so 12, we can think, well, that's 2 times 6. 2, we got a prime number, so we're going to keep that. 6 is not a prime number. That's actually 2 times 3. Okay, so prime number, prime number. So we have our prime factorization. 2 times 2 times 3 gives us 12. Let's do the same thing for 18. Well, 18, even number, we can say that's just 2 times 9. Right? With prime number, so we can hold on to that, and let's move over to 9. 9 is not a prime number. Well, 9 is actually 3 times 3. Prime number, we're done. We're down to just a multiplication of prime numbers to give us 18. So now to find the greatest common factor between 12 and 18 is we just collect up everything that's in both sets. 2 times 2 times 3, or 2 times 3 times 3. Okay? So there's a 2 in both sets, so 2. There's not another 2 in both sets, so that we can see that there's a 3 in both sets, times 3. This has another 3, but this doesn't have another 3, so we are done. The greatest common factor between 12 and 18 is 2 times 3, or 6. Okay? So 6 is going to be at least part of, if not the entire, factor that we're pulling out from our binomial here. Okay, is there anything else common to both of these terms? In other words, variables. This has an x squared, this doesn't have any variables at all, so there aren't any other little bits of these monomials that pair up that can come out. Okay, so to find out what's left inside these parentheses, because this is what we're extracting from. What's left of this, once we divide out our greatest common factor, is what's going to be left inside of our parentheses. Because remember, multiplication and division are opposites of each other. To get this binomial here, we did a multiplication, the distributive property. So to pull that number back out, we do the opposite. We have to divide. So what is 12x squared divided by 6? Well, 12 divided by 6 is 2. There's nothing this 6 doesn't take anything away from the x squared, so x squared. Okay, plus, since this is an addition, that operation doesn't change. What is 18 divided by 6? 3. There's no variables to deal with, so it's just a straight division problem. And we can go back in and we can check ourselves by doing that distributive property problem. 6 times 2x squared plus 3. 6 times 2x squared, well, we just multiply these constants. 6 times 2 is 12. The x squared doesn't have anything to multiply with, so it just stays x squared, plus 6 times 3 is 18. So we can see a process by which we can take a binomial and do kind of an order of operation. Well, I don't want to say order of operations, but apply a system to it so that we can figure out what two things multiply together to get that, right? We want to find the factors that multiply together to give us this. Okay. So let's run through just another example here real quick, just to give you a better feel. So let's say we have 4x to the third minus 28x squared. And we want to factor this. And we want to turn this into a multiplication of a monomial and a binomial. Okay, well, what's the greatest common factor between 4 and 28? Well, 28 is divisible by 4. So, in fact, in this example, 4 is our greatest common factor. Okay, well, now we go to the variables. What's the biggest number of x's that can come out of both of these terms? Well, we can take 2 out of this one, but we can take 3 out of this one. Okay? If we try to take 3 out of this, it won't work. Right? 3 squared out of this, it won't work. We'd end up with a negative exponent in some way, and we don't want that. So the biggest number of x's, so to speak, common to both of these terms is 2. So x squared. Okay, so that's the biggest exponent. Or sorry, it's the smallest exponent. Okay, so now we just do that division. 4 divided by 4 is 1. We don't write the 1 when it's a coefficient of a variable. And so x to the third divided by x squared is just x. Minus, because this operation continues on. And 28 divided by 4 is 7. The x's would just cancel each other out. X squared divided by x squared, or x squared divided by x squared, is just going to give us 1, and 7 times 1 is just 7. So here is our factored equivalent expression to what we started with. Okay, so take a look at the worksheet if it's in front of you, see how you do on those. Otherwise, if you have questions, just ask.